ready, and then we'll go ahead and start our recording and get ready to go. All right, Christine, how are you doing? Kayla, good to see you. How are you? Melanie, haven't heard from you yet. How are you doing? Jennifer, you too. Want to hear from you. Ayla, how's it going? Awesome. There we go. I see some more people in the chat box. Perfect. Hi, Kayla. How are you? Going camping this weekend. Oh, that's lots of fun. Well, a little sick. I'm sorry, Melanie. I hope you feel better soon and that it doesn't get any worse. I hope you get to sleep over the weekend and feel better. I'm sorry about that. Well, let's go ahead and get started. That way we can get to our weekend and Melanie can start to feel better. All right, so this is a reminder, class sessions are recorded and distributed for learning purposes that are listed here. Remember to be respectful, use school-appropriate language, participate often and well, do not share contact or social media info during classes for your own security reasons. All right, there are only 16 days left of the quarter. We are in week 10 out of 13, so today is Friday, October 23rd. We're going to start off Unit 6, which is our Intro to Organic Chemistry, and we will be completing the 6A assignment. For this last unit, we don't have a project because we will have a final exam. So keep that in mind that we will be working on a final exam at the end of this unit, which will cover Units 5 and 6, for which we didn't have a project for them. So just keep that in mind. All right, so organic chemistry, we're going to be talking about the field of organic chemistry, talking about the macromolecules, proteins, carbs, lipids, and nucleic acids. And we will also be taking a look at things that are called functional groups. And you can see here, we'll take a look at how organic chemistry is related to things like plastics and to food. So today we should be able to identify the characteristics and different types of organic molecules and explain the relationship between monomers and polymers. We will be completing the 6A assignment, and you can see our agenda over here on the right. Let's go ahead and at this point begin to open up our 6A assignment. I'm going to go ahead and send the link to you in the chat box. Go ahead and then give me green checks once you have it open and ready to go, open and started. Remember, click the link in the chat box, click Start Quiz. To get it opened, and then go ahead and give me a green check. It's also in your grades tab if for some reason the link in the chat box does not work. Hi Ryan, hi Anne-Marie, how are you doing? Go ahead and get this link open. I'll go ahead and put it on the board as well. Oh, that's weird, it didn't paste with it. Hold on one second. Let's try that again. Sometimes it chooses not to paste with the link live. I don't know why it does that. All right, let's go ahead and try that one more time. There we go. So there's a link up on the board for you if you want to get it from there as well. All right, I do need green checks from everybody. If I don't get your green check, I'll go ahead and check in with you in the check-in room. Waiting on green checks from Anne-Marie, from Jennifer, and from Anthony. All right, Anne-Marie, green checks, please. Anne-Marie, green checks. I know you just joined us, but I do need a response from you. Anne-Marie, green checks, please. Hello, hello. Go ahead and give me a green check once you have your assignment open, or let me know in the chat box if something is going on. But I need some response from you, please. Perfect. All right, looking good, everybody. Let's go ahead and move on. All right, what I want you to go ahead and do is tell me in the chat box, what do you think of when you hear the word organic? So the word, thank you. The word organic is a pretty popular topic nowadays. So go ahead and tell me in the chat box, what do you think of when you hear the word organic? Go ahead and let me know in the chat box. I see Jennifer typing. I see Christine typing. Make sure you are participating. Remember, participation makes class go faster, which means we get done earlier, as well as it helps you learn. You think of your aunt, Ayla. Why do you think of your aunt? Awesome. I see Christine. I see Ryan and Kayla in the chat box. Yeah, let me go ahead and type these things up on the board. Right, so we think of plant-based or just plants in general. You think of your aunt. I'm still waiting for your explanation on why, and then we'll get that up on the board. She only eats organic things, right? So we think of like organic food at the supermarket, right? I think that's where we're getting that from. You can think of healthy, absolutely. Any other things that you think of when you hear the word organic? Hear the word organic. She uses organic cosmetics, right? Yeah, there are definitely organic cosmetics. Things that have no GMOs, which are genetically modified organisms. All right, awesome. Cosmetics, I spelled that wrong. Cool. All right, cool. So taking a look here, yes, all of these things are how the word organic is often used in our everyday lives. However, we're going to learn today that the word organic has a much simpler definition, and it's kind of been co-opted by the food industry to mean something that it doesn't quite actually mean. So yeah, when you think of organic, you often think of healthy without like extra chemicals and plants, but that's not actually what the word organic means. So let's go ahead and take a look at how the food industry is getting it wrong. So the word organic means anything that contains carbon, which includes you and I. And are you and I plants? Tell me in the chat box, are you and I plants? Hopefully we know this. This is a biology lesson. Are you and I plants? Awesome. Yes, I see Christine in the chat box. I see Natalie typing. No, we are not plants. We are animals, but animals are still carbon-based, which means that we are still organic. So if you've ever, for example, watched Star Trek, oftentimes they'll say that, oh, this planet has a carbon-based life form, and that includes Earth. We are carbon-based life forms. All living things on Earth contain carbon, making them organic. So the word organic just means related to living things, right? The word organic just means related to living things, okay? Which includes you and I, not just plants. And those plants could be entirely genetically modified. They would still be considered organic because they are still carbon-based. So organic compounds are compounds structured around carbon. They include anything that is currently living or that has ever lived. And we'll take a look at how that's related to plastics a little bit later. Now, inorganic compounds, the prefix in means not. That's a little bit of an English connection. So inorganic means not organic. Inorganic molecules are not structured around carbon. So this could be, for example, things like silicon dioxide, which is also known as quartz. It's like a pretty mineral. Aluminum, which is a metal. H2O, which all living things need, but it itself is not structured around carbon. So H2O is itself not organic. It is just a fluid that organic beings use. So that would be water. And hydrochloric acid, a connection to our last unit where we talked about acids and bases. Hydrochloric acid is not structured around carbon, so that is an inorganic compound. How do we feel about that so far? Go ahead and give me a music note if you're feeling pretty confident about this. We're going to do a check for understanding in just a little bit. So I want to make sure that we are feeling confident about this. Perfect. Okay, let's go ahead and talk a little bit more in depth then about this atom that organic compounds are centered around. And that atom, again, is carbon. We took a look a lot at carbon in one of our previous units when we introduced atoms. And carbon is a really interesting atom. It's extremely versatile, and it can form millions of different arrangements. Now, the reason it is so versatile is because of its valence electrons. Take a look at our carbon, and let's go ahead and review this from a previous unit. Ignoring the center, how many valence or outside electrons does carbon have? How many valence or outer electrons does carbon have? Awesome. Yeah, it has 4 valence electrons, which means that if it were to act like an ionic, if it were to participate in an ionic bond, it could either gain 4 electrons or lose 4 electrons. But most of the time, carbon actually does not participate in ionic bonds. Most of the time, it participates in covalent bonds. And when it participates in covalent bonds, it can actually create 4 chemical bonds, which for most atoms is the maximum number of bonds that could be created, with some exceptions like silicon, for example. Silicon fluoride can have 6 bonds. But for the most part, carbon is going to be able to make the most amount of bonds of any type of atom. Go ahead and give me a star if that makes sense. It has the perfect number of valence electrons to make 4 entire bonds, unlike most other atoms. Now, in addition to this, because we did mention there are some exceptions to this, in addition, the other reason that carbon is so versatile and used for living things is because carbon is the small one. So carbon is one of the smallest atoms. and it can fit into parts of very large molecules. So you can have lots and lots of carbons that are all connected to each other, and they can still work really well together because carbon is so tiny. Other atoms, like I was talking about, like silicon, fluoride, which can have 6 bonds, or other things that are in carbon's family. So let me go ahead and take a look here. All right, so for example, in carbon family, we also have, silicon, germanium, tin, and lead. Those are all much larger atoms, and so those larger atoms, even though they can still do 4 bonds, they're not as versatile, and so that is why living things are not based on those. All right, you can see some examples of how carbon can arrange itself. It can arrange itself into groupings, into rings, into blocks, into branches. So carbon, again, is very versatile, meaning it can take many shapes. Many shapes. Awesome. This is going to be number 1 in your notes. Please give me a green check when you have it saved. I do need green checks from everybody to let me know that you are here and participating. 30 seconds. Here's the link again if you need it. Green checks. Go, go, go. Natalie, green checks, please, Natalie. Perfect. All right, I was like, I know Natalie's there. Perfect. Okay, let's go ahead and make sure that this makes sense. Go ahead, and I'm going to send you your polling tools and tell me how many valence electrons does carbon have? How many valence electrons does carbon have? Again, valence meaning those outermost electrons. We just reviewed that together. Perfect. I see participation from Amy, Annette, Kayla working, Natalie working, Ryan on top of it. I see Christine. Awesome. Ayla in the chat box. No worries. That's fine too. Excellent. Let me go ahead and publish these up on the board. And you are definitely all correct. I would agree. Carbon definitely has 4 valence electrons. Again, those 4 valence electrons allow it to make 4 covalent bonds, which is more than almost every other atom on the periodic table. Let's go ahead and answer that one in our assignments. I'm going to go ahead and give you those green checks again. Green checks for number 2. Let me know once you have number 2 saved. Jose, make sure you open that up, and then give me a green check once you have number 2 saved. And number 1 will be in the recording uploaded around 1 to 2 p.m. All right, just waiting on Anthony B, Jennifer, and Jose. Anthony B, Jennifer, and Jose, green checks, please, for number 2. Thank you, Jennifer. Anthony, Jose. Anthony, Jose. Thank you, Anthony, Jose. Jose, green checks for number 2. Are you there? I know you just logged in, but please go ahead and give me a green check. All right, I'll give you a little bit of a grace period, and then we'll go ahead and check in with you later if I don't hear back from you. Cool. All right, let's go ahead and talk a little bit about fossil fuels. So fossil fuels are, in fact, organic compounds. They're organic compounds called hydrocarbons. The reason they're called hydrocarbons is because they're made up of hydrogen and carbon, and only made up of hydrogen and carbon. So that is where that name comes from. You can see example up here on the right. This includes things like coal, petroleum, and natural gas. So basically, a lot of the ways that we power our current United States. So petroleum also makes products like asphalt, fuel oil, gasoline, and other synthetic products like plastic, which in fact we're going to talk a little bit later, means that plastic does originally start out as an organic compound. Now the reason fossil fuels are made up of these, are in fact organic, again, is because they are based on living things. Think about the term fossil. Tell me in the chat box, what does the term fossil mean? Go ahead, brainstorm with me in the chat box. What does the word fossil mean? Awesome. I see Kayla. I see Melanie typing. I see Ayla working. Sorry, my video keeps on lagging. I don't know why. What do you think of when you think of up here, right? You think of old. I generally think of dinosaurs. Does anyone else think of dinosaurs when you think of fossils? Go ahead and give me a thumbs up in the chat box if you've ever thought of like a dinosaur fossil. If you've ever associated dinosaurs with fossils. Okay, good. Good. All right, so yeah, so fossil fuels are made from dead material. All right, specifically they're mostly made from dead plants, but dead animals can also be decomposed into fossil fuels. So that is why they are still considered organic. Remember, organic means living or has once lived, and so fossil fuels were made of once living organisms. So an example here would be natural gas. Natural gas is 77 to 92% methane. And methane we learned about in our unit on compounds is CH4. Again, made up of carbon and hydrogens. It's a hydrocarbon. It's a fossil fuel. So it's a hydrocarbon that burns very easily and cleanly, generally making it a good fuel. This is, in fact, if you have a gas stove, methane is probably what is powering your gas stove. However, methane can escape into the atmosphere, and any methane that escapes into the atmosphere can be harmful to the environment because it can trap heat. All right, so that's going to be true about a lot of our fossil fuels, is that fossil fuels are really good for giving us everyday power, but they do end up being pretty bad for the environment long term. Here's the combustion reaction. Again, we learned about this a few units ago, so you can see methane, CH4, plus 2 oxygen molecules will give you carbon dioxide, water, and heat. So that is what combusts. That is what you get in your stove. All right, let's go ahead and match these up and make sure that these make sense. We talked about organic compounds, inorganic compounds, and hydrocarbons. Go ahead and match those up for me up on the board, and let's make sure that we understand those. Which one is made up of only hydrogens and carbons, including coal, petroleum, and gas? Which ones are structured around carbon and related to living organisms? And which one is non-carbon based, such as aluminum, water, and hydrochloric acid? Go ahead, get your answers up on the board. Let's see who I see working. I see Ayla up on the board. I see Anthony working, thank you. I see Annette and Jennifer and Christine. Oh, lots of people up there. Awesome. Natalie working. Perfect. Amy, I see you. Ryan on the board. Great job. Love those colors. So pretty. Awesome. Looks like we're feeling pretty confident. Let's go ahead and check our answers here. Let me shrink this down a little bit. I'm going to do the answers in red to confirm. And let's take a look here. Yes, organic compounds, you are correct. Organic means anything that was living or once living. It's structured around carbon. Inorganic means they are non-carbon based, like aluminum, water, and hydrochloric acid. Again, even though we use water, it doesn't have carbon in it, so it must be inorganic. And hydrocarbons are only made up of hydro, from hydrogen, and carbon, carbons, including coal, petroleum, and gas. This is number 3 in your notes. Please give me a green check when you have this saved. You have 30 seconds. Go, go, go. Green checks from everybody, please. All right. Oh, perfect. We got all the green checks in before the timer even went off. That's amazing. All right, so carbon-based molecules are oftentimes structured in very long chains, and these very long chains are called polymers. Now, does anybody know in the chat box, what does the prefix poly mean? Okay, what does the prefix poly mean? Can anyone think of that in the chat box? If not, I can give you a hint. It actually does not mean one. All right, so poly, let's think about poly, instead of like one, which is like mono, or 2, which is di. Poly actually means many, but you're definitely on the right path that this is related to like math. So poly actually means many, all right? Which should begin to make sense that polymers are really long and they're going to be made up of many, many pieces, okay? So a natural example would be carbohydrates. How many of you can think of a food example related to carbohydrates? How many of you can think of a food example related to carbohydrates? Yes, pasta, that's a delicious carbohydrate. My parents, oftentimes when I was growing up, would go on diets where they didn't eat carbohydrates, and I just didn't understand it because pasta is delicious. Any other examples we can think of for carbohydrates? Amy, Anne-Marie, Annette, Anthony, Jennifer, Jose, are there any other examples that you can think of for carbohydrates? Ryan, Natalie. Yeah, exactly, Anne-Marie. Bread, absolutely. So these are all examples of natural polymers, naturally carbon long molecules. So again, things like bread, things like pasta. Now, a synthetic example, the word synthetic meaning man-made, would be things like plastic. So man-made would be things like plastic. So polymers are made up of individual units that are called monomers that get linked together. So again, polymers are the big pieces made up of many parts. So polymers are big and made up of many parts. And those little parts are called monomers. Now, Christine, jump in here and tell me, what does the prefix mono mean? And anyone else can jump in here too. What does the prefix mono mean? Yes, exactly. So the prefix mono actually does mean one. All right, so monomer is going to be a single piece, so a single part. All right, so you can see an example down here. The monomer is the small single one piece, whereas the polymer is the big one made up of many pieces. In the chat box, please go ahead and give me a birthday cake if you understand that so far. So monomer is the small one, polymer meaning many, is the big one. Excellent. Thank you, Annette. Thank you, Ryan, Natalie, Christine. I see you in the chat box. Thank you, Kayla. Yeah, so octane is going to be an example here. Octane is a component of gasoline that you might use in your car if you've ever heard the term high octane gas. That's because gasoline does include octane. And it has the chemical formula of C8H18. And it's actually made up of 8 repeating methane molecules. Remember, we just learned about methane on the previous couple slides, right? Here was our example of methane right here. So if methane is your single monomer, your single piece, if you put a bunch of methanes together and link them up, that is going to create octane. So 8 repeating methane molecules linked together, that creates octane. So in this instance, methane is the monomer, the small single piece. And octane is the polymer, the big compound that's made up of many parts, in this case, many methanes. All right, let's go ahead and make sure that this makes sense. I'm going to go ahead and give you your whiteboard tools. Box the correct words on the board. Polymers, are they the small or the large molecule? Remember, the definition of a polymer is long chains of carbons. And monomers, are they the small or large molecule? Remember, a monomer is a repeating unit in an organic compound. Go ahead, box those up on the board for me. Let's begin to practice that. Let's see who I see up there. Great, I see Christine and Ryan jumping up there right away, working fast. I see Natalie on the board too, participating. Jennifer working. Let's get some participation from Amy and Anne-Marie and Annette. I see Ayla up there. Let's get my other A names up there. Thank you, Annette. Jose, get your answers up there. And let's see here, am I missing anyone else? Melanie, I'd love to see your answer up there too. Awesome. Good, looking good. We have so many answers up there, it's hard to see. So let me go ahead and go over these. Yeah, so polymers we just talked about. The prefix poly, right, means many, and that should help you remember that a polymer has many pieces, making it the large molecule. Excellent job on that. Let me go ahead and box that for us for our final answer. And taking a look down here, go ahead and point for me on the board. Which one of these would therefore be the polymer? Go ahead, point for me up on the board. Use your pointer tool. That's going to be the second tool. Click on the board so that I can see your pointer and tell me which of these would be the polymer. Excellent, good. I see these people getting up there. Perfect. Yes, so this big one down here made up of many repeating parts, that is the polymer. Great job, everybody. Now the monomer, on the other hand, is going to be the very small molecule, and it's going to repeat when it's inside of a polymer. All right, so you can see this one right here is our monomer. And you can see that it is, in fact, repeating, right? So you can see it repeat once, twice, 3 times, and 4 times in this example of the polymer. This is number 4. Go ahead and fill these in and give me a green check when you have them saved. You have 30 seconds. Ready, set, go. Work quickly and give me green checks. All right, looking good, Jose. Let's go ahead and get that green checks. Green check for number 5. I know you're there. Go ahead and give me that green check for number 4. Number 4. Jose, are you there? All right, Jose, I'll go ahead and just check in with you in just a moment. Oh, no, good, awesome, I see your green check, perfect. All right, let's go ahead and keep on moving here. All right, so the last thing I want to kind of go over is, again, we mentioned how plastics are going to be related to organic compounds. So plastics are still considered organic because we mentioned that they are made from fossil fuels, and fossil fuels are mostly made up of dead plants. So they are synthesized or man-made from, right? Synthesized means to be made, man-made from. So they are man-made from organic materials, so fossil fuels being mostly dead plants. An example here would be ethylene gas. Ethylene gas, which is C2H4. You can see a molecule of it up here. And this is naturally produced by fruits while they're ripening. How many of you, for example, have ever put a banana next to an apple and the banana like instantly turned brown? How many of you have ever done that? Or for example, how avocados, you leave them out for like a second too long and they're already gone. They're already bad. How many of you have ever done that? Go ahead in the chat box, give me a star if that's ever happened to you. So things like bananas and apples and avocados. Yeah, exactly. So all of these things produce ethylene gas, and they can actually affect each other. So the apples will actually produce a lot of ethylene gas, which will make bananas ripen too quickly. That's why you don't store bananas next to apples unless you want them to ripen quickly. Now what happens here is that ethylene gas, which comes from dead organic material, is then polymerized. It undergoes a process, a man-made process of polymerization. And polymerization, you can see that it has this prefix of polymer. So it turns ethylene into a polymer. It links all of those ethylenes together. The ethylenes are the single unit, the single monomer. And as they get polymerized and linked together, it becomes the polymer. In this case, it becomes polyethylene. You can see those repeating units right here of ethylenes, and polyethylene is a plastic. Specifically, it's a plastic that's often used in things like grocery bags, like these baggies that you see up here. This one's kind of a joke down here. You can see here that when you recycle, right, powered by recycled dinosaur. So they're saying that fossil fuels are made from recycled dinosaur. Now again, most of that's not technically true. Most fossil fuels are dead plants, but I'm sure that the occasional dinosaur has snuck into a fossil fuel as well. All right, this is number 5. Go ahead, give me green checks when you have that saved. Fill in the blank with the word synthesize. 30 seconds. It's a long word. Make sure you spell it correctly, otherwise the computer will mark it wrong. So make sure you spell correctly. 7 seconds. All right, Jose, Melanie, green checks please for number 5. I want to make sure I don't leave anyone behind and that your assignment is ready to submit. Looking good. All right, so this one is one that we did all together because it's an intro lesson, so there wasn't a ton of application questions. So go ahead, submit that, and hopefully we got all A's. If you did, go ahead, shout them out in the chat box and let us know how did you do today. Awesome, Annette, good job, Amy. Ryan, great to hear. Thank you, Natalie. Awesome. Okay, so if you did miss anything, make sure you go back to the recording. It'll be uploaded around 1 to 2 p.m. Again, for this lesson, we went over all the answers together because we're going to go more in depth in some later lessons. So this one was just kind of our intro, our starting one. Perfect. So today we talked about organic molecules and how to explain the relationship between monomers and polymers. We completed the 6A assignment together. Let's go ahead and reflect on the whiteboard. How would you rate your understanding of today's objectives? How would you rate your understanding of today's objectives? So make sure you actually click that button up on the board, otherwise we won't be able to see it. Perfect. All right, good. I'm seeing about 6 of us up on the board so far. Let's get some more participation up there. Looking good. Awesome. Perfect. All right, so I'm seeing most of us fall on the right side. That's good to hear. That's where we want to be. If you do feel like you're very confused or still need some help, remember to email and reach out, and we can set up a one-on-one tutoring time. But I'm glad to see that most of us are feeling pretty good or awesome about today's topic. Again, it's just an intro, so we're going to continue going more in depth as we walk through the organic chemistry unit. Great job, everybody. All right, so for today's attendance, go ahead and tell me in the chat box, organic compounds must contain what atom? Go ahead and tell me in the chat box. This is, again, if you did our notes today, you should feel pretty confident with us for today's attendance. What do organic compounds, what must they contain? Awesome. I see Christine in the chat box. I see Natalie, Melanie, Ryan in the chat box. Great. I see Ayla working. Looking good, looking good. All right, awesome. So that is the correct answer. I see that you all have the correct answer. Go ahead, fill that out for today's attendance discussion. Remember, click the link, click start a new thread, and then make sure you write the entire sentence. So I'll go ahead and write that reminder up here. All right, so write the entire sentence. All right, that way you have it saved for your review, right? So organic compounds must contain what? I see the answer in the chat box. You guys are all on top of that. Awesome. Go ahead and get that filled out, submit that. I'm going to go ahead and start logging people out in about 1 minute. And look at that, we actually finished a little bit early, which makes up for every single class that we've never finished early. Thank you so much, everyone, and I will see you later. Have a wonderful weekend. All right, thank you, everyone. See you later. let me know if you need anything. Bye, everyone.